Hello everyone, welcome to this video. In this video, I'm going to discuss about how we can perform object detection on top of our custom data with the help of YOLO v5. If you don't know, YOLO v5 is an state-of-the-art object detection model. So with the help of this particular YOLO v5, we'll be learning how we can perform object detection on top of the custom dataset. So in this particular video, I'm going to discuss each and every component of this particular YOLO v5, like how we can set up this particular YOLO v5, how we can prepare our custom data, and on top of this custom data, how we can efficiently utilize this particular YOLO v5 model and how we can do the custom training operation. So after the training, I will also show you how we can inference on top of our custom data. Even I will also show you the live prediction with the help of web camera. So this is going to be completely end-to-end discussion. So make sure you are watching this particular video till the end, and I hope at the end of the video, you'll be learning each and everything about object detection with the help of YOLO v5. So instead of talking too much, let's start with our agenda. So first of all, let me write down all the agenda actually I'll be covering in this particular video. Then I'll be starting with our implementation. So at the very first, I'm going to discuss about YOLO v5. Okay, but exactly this YOLO v5, I will also show you the official GitHub repo of this particular YOLO v5. Okay, then after that, I'll be showing you how we can set up YOLO v5. Then we'll be learning about how to prepare training data. Then after that, we'll be learning about custom annotation. So what is annotation? I will discuss each and everything, because whenever you are performing any kinds of object detection task, first of all, you have to perform the data annotation. That means you want to generate a label of your image, and that particular label with respect to the image actually you will be giving to the model. Your model will be learning about the object. So that is why actually custom annotation is very much required. And here I'm going to discuss about some of the open source tool you can use, okay, for the annotation purpose. Then fifth, I'm going to show you how to configure YOLO model. Then I will also show you how we can start the training. After training, we'll be discussing about the evaluation. Then we'll see that the test inference. Then at the last, I will also show you the live object detection part. Detection with webcam. And here I'm going to use single image prediction. Single image prediction. And at the last, I will also show you how we can create a web application. Okay, web application. So we'll be creating one web app so that if someone is using your application, and they'll be doing this kinds of object detection task. So yes guys, this is the agenda for this particular video. And now I'm going to discuss each and every component in detail. So make sure you are watching this particular video till the end. So first of all, let's try to see about YOLO v5. So if you want to know about YOLO v5, so you can search on Google YOLO v5. Okay, YOLO v5. So that is the official GitHub actually will get of the YOLO v5. So YOLO v5 is nothing but it's a state-of-the-art object detection algorithm. So it is having lots of variant. If I show you the model view, as you can see, it is having lots of pre-trained model variant. So it is having YOLO v5n model. That means this is the nano model. It is having another model called YOLO v5s model. This is the smallest model. M means this is the medium model. L means this is the large model, and so on. Okay. If you check this particular model, this size is increasing as well as the parameter size is also increasing. Now you have to choose the model with respect to your task. Let's say you want to create an application and that will predict real time. So you don't want to get any kinds of lagging during prediction. So at that time you can go with lighter model, that means the smaller model, because it is having lesser parameter. So there actually will get like very fast speed. But whenever you are worrying about the accuracy, you are not worrying about the speed, at that time you can go with bigger model. Let's say you are working in the medical domain, their accuracy matters a lot instead of the time. So that time actually you can use bigger model. So with respect to your task, actually you have to select the model. But in this particular video, I'm going to use this particular model called YOLO V5S model. So here the problem statement I'm going to solve with the help of this particular model, it can be easily solved. I'll discuss about the problem statement. Even I will also show you the dataset, which dataset actually I'm going to use in this particular video. But here you can use any kinds of dataset. I'll show you the dataset hub as well, like where you will get the dataset, all kinds of dataset actually you can download, and you can perform the object detection on top of it. So yes guys, this is the brief introduction of the YOLO V5, and you can also see the benchmark of this particular YOLO V5. So it is having lots of version actually, YOLO V5, then YOLO V6, V7, V8. Currently actually V9 also came in the market. So YOLO V5 is a pretty good model. You can see the benchmark. So it is having different variant, as I already told you. So here you can see the COCO API score, that means the average position score with respect to all the model variant, and as well as their speed, okay, on top of this particular GPU. So guys, here you can see the benchmark table. So you can see the different model variant actually. They have trained and they have collected the API score as well as the faster speed, okay, on the GPU. So you can see all the model like YOLO V5, N model, S model, M model, okay, all the model performance you can see here. So it's like pretty good model. You can use it if you are having any kinds of object detection tasks. So you can use this particular YOLO V5 model, okay, on top of that. So most of the tasks actually it can solve very easily. So guys, now let's try to see how we can set up this particular YOLO V5 and how we can perform object detection with that actually. So for this, I already prepared one collab notebook for you. So let me show you this particular collab notebook. Yeah. So all the steps actually I have mentioned here. So I will share this particular code in the resources section. So there actually you can download this particular file and you can execute from your end. So if you want to use this particular YOLO V5, and if you see here, YOLO V5 is the research from Alternalytics. So this is the organization, they have proposed this particular model. And this is not just a model, actually, they have also created one framework. Okay, they use the same name called YOLO V5. And this is the official repository of this particular YOLO V5. So what you have to do, first of all, you have to clone this particular repository. Then after that, you have to install the requirements actually they have shared with you. Okay, so this is the requirements actually. So these are the library and tool actually you have to install. Then you will be utilizing this particular YOLO V5 in your system. So first of all, what I have to do, I have to open up one collab notebook, which I have already opened. Now here you just need to select the GPU as a runtime. So let me select the GPU as a runtime. So I'll just click on the change runtime type, and here just try to select the T4 GPU. If you are using free collab, so by default you will get this particular GPU. But if you are also using Collab Pro or any other collab subscription, so you can get A100 GPU and V100 GPU as well as the T4 GPU. Sorry, L4 GPU. So here I'm using free collab, that's why I'm going to use this particular T4 GPU. Now I'll be saving this particular T4 GPU, and here I'll connect my notebook. So guys, as you can see, my collab notebook has connected, and here I got the virtual RAM and virtual disk and virtual GPU as well. Now what I have to do, first of all, I have to clone this particular official repository of the YOLO V5. And if you want to clone, so this is the command git clone. And now you just need to get the link of this particular repository. So just click on the code and copy the link address and just try to mention it here. So I already mentioned. Now after that, actually I'm redirecting to this particular folder called YOLO V5. Okay, now let me show you. So if I clone this particular repository. So guys, my repository has been cloned. Now if I refresh, see guys, this is the YOLO V5 repository I have cloned. Now with the help of this particular cd command, cd means change directory, I'm going inside this particular YOLO V5 directory. Now if I just show you my present working directory, if you see, I'm inside YOLO V5 folder only. Now inside YOLO V5, I'm having this particular file called requirement.txt. Okay, this particular file actually I need to install. Now if I want to install this particular file, so I have to execute this particular command called pip install -qr requirement.txt. So it will install that particular requirements in a quiet mode. Then after that, I'm just importing the torch library and I'm just checking the version of the torch and all, right? So let me install and show you. If the installation is successful, that means everything will work. And if you are facing any kinds of issue, so definitely you have to fix that one. but I believe you won't be getting any kinds of error because I already checked this particular notebook and it is working fine for me. And I hope it will also work fine for you if you're following me so far. So let's wait, guys. So I'll come back once this installation is completed. Then I will show you the import statement. So guys, as you can see, my installation is completed and here is the Torch version I got and the CUDA version I also got, which is nothing but 12.1. So you can check this particular version. Let's say whenever you are setting these things in your local machine, that time you have to take care of this particular version. So make sure you have CUDA 12.1 in your system. Okay, otherwise it will get some issue. So guys, it is installed successfully. Now what I have to do, I have to prepare my custom data. So custom data wise, actually I'm going to use here sign language data. I think you already know what is sign language. Sign language is nothing but it's just a sign. Okay, sign of a language. Let's say there are some dumb people, they can't talk and they can express their actually language. So what they use, actually they use this kinds of sign activity. Let's say if they're doing like that, that means they're trying to say hello. If they're doing like that, that means they're trying to say thanks. Okay, so this is the sign language actually activity. So here I already have some sign language data with me. So let me show you the sign language data. So guys, this is the data I already prepared. I'll show you how we can prepare this particular data and where you actually will get these kinds of image actually. So this image actually I collected with my web camera. So you can open up your web camera and you can click this particular image. Okay, let's say you just try to show the activity of the sign language and you just capture this particular image. With the help of OpenCV also you can write lots of automatic script. Like if you just open up your camera and it will automatically capture your image and you just need to show the move. So that's how actually I collected some of the image. So in the training folder, I am having 120 example, but whenever you are doing your actual training, so make sure you have lots of image here. Okay, just to show you the training demo, I just kept 120 example, but make sure whenever you are training your actual model, you are increasing this particular image size. Now here, if you see guys, I am having different image. So this is called actually please. So if you do like that, that means you are trying to say please. So here I'm having 6 level. So you can see please, thanks, then I'm having no, then hello, I love you, then yes. Okay, I think yes is also there. Somewhere yes is also there. Let me show you. Yeah, so you can see yes is also there. So now let me show you all the label one by one. So this is nothing but this is thanks. So if you do like that, that means you are trying to say thanks. And if you do like that, that means you are trying to say yes. So this is the American sign language, but if you are doing for the India or any other country, there this activity will change. Okay, you can search about this particular sign language on Google. Let's say sign Indian sign language. Okay, if I search for Indian sign language, you will see Indian sign language gesture would be a little bit different apart from your American one. See, so you are having lots of sign language. So you can visit website, you can visit different link and you can try to learn how to express for the Indian sign language. But here I'm going to use this particular American sign language. Okay, so this is the American sign language. Okay, and here I collected only 6 level. Now you can see this is the yes and this is the please. So if you do like that, that means you are trying to say please. And if you want to say thanks, so you have to show like that. That means thanks. And if you want to say, let's say no, so you just need to do like that. That means no. And there is another one called hello. Okay, as you can see. Okay, I think I forgot to show you the I love you one. See, if you want to tell I love you, so you can show like that. And the last one is the hello one. So here is the hello. Okay, it's like very simple. So this 6 level actually I collected with the help of my web camera. You can also collect with your web camera. Okay, it's like very easy to collect. Now you can also get the data from different website as well. So you can also visit something called kaggle.com, Kaggle dataset. Okay, Kaggle dataset is also having lots of sign language data. So here you can search about sign language. Okay, image. See guys, you are having lots of sign language, as you can see, lots of sign language data. Now you can download any kinds of sign language data and you can use it in your project. Apart from that, you can also use something called RoboFlow Universe. So you just need to visit this particular website called roboflow.com. So RoboFlow is a computer vision platform. So here you can perform all kinds of job inside computer vision. So for the data annotation purpose, I'm going to use this particular RoboFlow website. Okay, I'll tell you how we can use this particular RoboFlow for the data annotation part. So make sure you have one account. So I already have one account. So I'll just try to log in with my account. So you can create the account with the help of Google account. So it will take only 1 minute to create your account. So please try to create the account. I'm not going to show you like how to create the account because this is like very easy. Then here you will see something called universe option. Just go to the universe, and in the universe actually you are having, see, that much of data set. Okay, that many of data set. Okay, so now you can search any kinds of data set. Now let's say you want to do sign language, so you can search for sign language data, and here is the search button. So you will see different sign language data will come. See guys, different sign language data will come. Now you can also directly download this particular data. So now let's say I want to use this particular data. I'll click on this particular data. Now here if you see, one option called download dataset, just click on the download dataset option. Now here you have to download as a zip file and just try to select the format. So here you have to select YOLO v5 because here we are using YOLO v5 model. So here is the YOLO v5 PyTorch. So you have to select this particular option and you just need to click on the continue button. So it will start downloading. It will automatically zip everything and it will start downloading. See, it has started downloading. That's how you can also get the data from this particular RoboFlow universe. So not only sign language data, if you want to do any kinds of thing, any kinds of projects, all kinds of data are available. Let's say I'll show you. Let's say you want to do card detection, then player detection, okay, then painting detection, card detection, okay, then you are having also, let's say, people detection, all kinds of, see, industry safety detection, all kinds of data are available. Just search over any kinds of data. If you're looking for, just try to search over RoboFlow universe, or else you can also search over this particular Kaggle website. So here actually most of the data you will get, and if you're not getting the data, that time you have to collect your own data. But collecting data is very much costly task. So for this you need time, you need lots of like manpower. But first of all, I will suggest whatever project actually you are doing, try to find the dataset over the internet. So that's actually you can get the data, guys. So I already show you my dataset. This is my dataset, and I already done the annotation. See, these are the annotation file. These are the txt file because these are the annotation file. I'll show you how to generate this particular annotation file. But before that, first of all, let me show you why this annotation is really required for the object detection. So for this, I'm going to open up my Blackboard. And here, let me show you one demo. So let's say here you have one image. So this is one image. In this particular image, let's say you are having one cat image. And you just want to detect this particular cat. Let's say this is one cat. I'm not good at drawing, so just try to consider this is a cat. And let's say there is a person also. There is a person in this particular image. So what you have to do for with the help of object detection, you have to detect this particular object. So let's say this is a cat. This is a cat, okay, and this is a person. This is a person. So how your model will locate that particular object? Initially, let's say you will having lots of data. Like initially you will be having lots of images. Now here you are using one model called YOLO v5. Okay, YOLO v5. This is the model. So during training, what you have to do? You have to feed this data set definitely to the model. But how your model will identify, okay, whether it's a cat, whether it's a person? For this annotation is required. Annotation. You can also talk about labeling. Let me write down labeling. Okay. So what is annotation and labeling? I think you know. So I think you know about supervised learning. In supervised learning, what we used to feed in the model, we used to give the X data as well as the Y data. So X data is nothing but my independent variable. Y data is nothing but my dependent variable, or we can also talk it as label. Okay. So I also need to prepare the label of this particular image file. So how to prepare the label? Let's say here I'm having one cat. Here I'm having one cat. So let's say this is the cat. So first of all, I need to annotate this particular cat as a cat. Let's say I'll create a bounding box and I will define as a cat. Okay, this is a cat. Now let's say here I'm having one person. I'll also annotate this particular image as a person. Okay, that means I'll create a bounding box. I'll just name it as a person. Then it will generate one annotation file. That annotation file is nothing but it's a txt file. I already showed you, I think. This is the txt file. If you see in the training folder, I'm having the image. With respect to the every image, I'm having the txt file. That means the annotation file. That means the label file. Now, if I open this particular txt file, you will see some information is there related to our data. Now you can see here you will get some of the coordinate point with the label. See guys, here you are getting some coordinate point. That means this particular 4 coordinate point. Let me show you. So this 4 coordinate point actually you are getting. So this 4 coordinate point you are getting here. So 1 coordinate, 2 coordinate, 3 and 4. So this 4 coordinate, that means the actual level location. Okay, you are getting the actual level location. So let me open this particular file again. So here you can see you are getting that particular actual object location and the object label. Okay, that means the object name in a numerical representation. So here 5 means it is just defining as a 5. I think you have heard of something called label encoding. Let's say you are having 6 different objects. Okay, let's say you are having hello, then yes, there's no, then I love you, okay, then please, and thanks. Okay, 6 different label you are having. Now you have to define the integer encoding. That means the label encoding for each of the label here. So let's say hello would be assigned as 0, yes would be assigned as 2, no would be assigned as 2, and I love you would be assigned as 3, please would be assigned as 4, and thanks would be assigned as 5. So that's actually a label encoder happens. So you can see here it is assigned with 5 here. It is assigned with 5. Now what exactly this 5 is? So if you want to know about the 5, like what 5 is representing, so you can open up your data again, and there is one file actually will get called data.yaml file. Now let me open this particular data.yaml file. I'll open it with the help of Notepad++. So here you will see that particular label name, actual label name. So see guys, this is the list of the label I'm having, 6 label. You can see NC, that means number of classes is equal to 6. And now you just count 0, 1, 2, 3, 4, 5. That means 5 means, okay, 5 means it is yes. Okay, you can see it is 5. That means it is yes. It is trying to say yes location. Okay, yes location. That means yes coordinate point. Okay, yes coordinate point, yes location. Now with respect to that, if you are getting 0, that means it's a hello. If it is 1, that means it's a I love you. If it is 2, that means it's a no, and so on. And this is the image directory location. If you see here, this is the image directory location. So inside training folder, I'm having the image. Inside image, I'm having all the images. Same I'm having for the, let me show you. Same I'm having for the validation as well. So this is the folder structure. Okay, this is the folder structure for the YOLO v5 you have to prepare. So this is the folder structure. Now for the testing also, I'm having the same format. Now you can ask me how to generate this particular folder structure automatically and how to generate this particular data.yaml file. So no need to worry, I will show you the annotation part. Once annotation is clear, you can easily generate this particular folder structure and this particular file with the help of RoboFlow platform. Now, first of all, what you have to do, I already told you, first of all, you have to collect your data. Okay, first of all, you have to collect your data. Let's say you have collected your data and your data set is ready. Now, what you have to do, you have to upload this particular data to the RoboFlow platform. Let's say these are my data I have collected. Just assume these are the data I have collected. So here you can keep your actual data, like all the data you have collected. But just to show you, I kept these are the example only. Okay. Now what you have to do, you have to log in up with this particular RoboFlow platform. So I already showed you how to log in with this particular RoboFlow platform. So once you log in, you will see this kinds of interface. So guys, if you open up this particular website, initially you won't be getting anything. Previously I did some project, that's why this project is coming here. So let me delete this particular project because previously I did one experiment here with the help of this particular data. So I'll delete this particular project, then I will show you. Okay, I will again upload this particular data here. Now I think sign language data is not there. Let me check. Yeah, it's not there. So first of all, what you have to do, you have to create one project here. So click on the button, create project. And here you just need to give the name of the project. Let's say this is YOLO v5 demo. You can give any name. You can give your project name. It's completely fine. Then you have to give the annotation group name. Okay, annotation group name means how many annotation group you are having. That means how many label you are having. So here I'm having different label. Yes, I love you. Okay, no, yes, please, thanks. So here I'm having 6 label. So all the 6 name you don't need to give. You can give only one name. Later on you can create. Let's say I will only give the hello here. Okay, hello here. Then here you have to select the project type. What kinds of project actually we're trying to do here. So here I'm doing object detection. If you're doing classification, instance segmentation, key point detection, you can select it. So going forward, we'll be also learning the instance segmentation, how we can perform the instance segmentation and all. But as of now, I'll be selecting this particular object detection. Now I'll just create this particular project. Now here, you just need to upload your data. So here is my data, guys. So what you have to do, just press Ctrl A, select all the data and just try to drag and drop here. So here I'm having 30 images. but whenever you are collecting your actual images, so it would be more than 30 images. Just to show you, I'm just keeping 30 images here. Now here you just need to click on save and continue. So it will upload all the data in the RoboFlow platform. Then you can start annotating on top of this particular data. Now see guys, you are getting some of the option. So just try to select this particular option, manual labeling. I'll start the manual labeling, and here I will assign the image. Okay, there is a button you can see. Okay, now here you will get the final button called start annotation. So I'll start the annotation. Now see guys, this is the annotation tool actually will get. Now you have to select the part of the object you want to detect. Now here I only want to detect this particular part, that means this particular hand part. Now what I have to do, right hand side you can see different options. So you have to select this particular option called bounding box tool. Just select this particular option and try to create one bounding box in a good way. Okay, make sure you are completing this particular object. So the more good annotation you will be doing, the more good learning your model will be, right? So here this is nothing but hello. I'll save this, and again I will go next. So this is also hello. So here make sure it is hello and save this again first. So this is hello again. I'll select this particular part. So that's how you have to complete for all the image. Okay, you have uploaded here. So this is also hello. So I'm doing quickly because I want to complete everything, but make sure you are doing in a good way. And that's it. That is why actually data annotation and data preparation is like very costly task inside computer vision. So you have to manually handle each and everything. Okay. But if you have the data, training model is very easy. I'll show you. It is just only plug and play kinds of things. You just need to upload your data in the notebook, feed the model, and you can easily train that particular object detection model. But preparing the data is like very like hard task here. So this is also done. Now see, this is I love you. So select again. And now make sure you are giving I love you here. Hello. You just need to write. Okay, sorry. I again need to select it. Yeah. So this is nothing but this is I love you. So I love. Okay, I love you. So now save enter. Now go to the next image. So this is also I love you. Done. Go to the next one. This is also I love you. So here you can consider any kinds of object you want to. Let's say if you want to detect car, that time you have to select the car and you just need to write the car in that particular label option. Let's say you want to do person detection at the time, just select the person and write the person. Let's say you want to do smartphone detection, just write select the smartphone and just write smartphone there. That's how you can use any kinds of data set here. Here I'm showing you with the help of sign language, but you can use any kinds of data and you can get the data from these are the open source platform. Okay, I already showed you. Now this is also done. I will go to the next image. So this is also I love you. I'll do it quickly because it will take time. So this is now no. So here you just need to write no. Save. Go to the next one. This is also no. This is also no. This is also no. This is also no. So here I'm just generating the label. I'm generating my actual y variable, that means y data, that means my label data, because this is a supervised learning. First of all, I have to teach my model. This is called no, this is called yes, this is called I love you, and this is the location of that particular object. So later on, whenever I'm giving any kinds of test data, my model will be able to detect that particular part, right? So this is called annotation, data annotation part. Now this is a please. This is also please. This is also please. Please. And this is thanks. Now this is yes. This is also yes. This is also yes. Yes. So that's how you have to complete for all the image you are having in your folder. See, the last one I have done. Now, if you see, I have completed 28 out of 28. Now, I'll just go back. And here you will see add 28 images to the dataset. I will click on this particular button. Now it will automatically perform 10 test split for you. Okay, you don't need to manually do it. Now I'll just click on add image. So this is the button you just need to click. Now just create a new version of your data. And now if you want to perform any processing, let's say you want to perform resizing operation and all, you can do it. Otherwise you can continue. I'll just do it continue. And if you want to perform data augmentation, you can also perform data augmentation. Augmentation means you can generate some more data, okay, with respect to your real-time data. So there are some augmentation technique are available. Let me show you the data augmentation. Data augmentation. So this is the data augmentation, guys. Let's say you are having one image. Let me show you one good example. I think I can take this particular example. Let's say this is the original image. So this particular image, actually you are rotating, you are cropping, okay, you are changing the contrast, color. So this is called data augmentation. You are referring the same image, but you are generating some variant of that particular same image. Okay, so this is called augmentation. So if you're having less data and if you want to generate some new data, you can perform the augmentation. So I'm not going to perform an augmentation. I'll just click on continue. Now I'll just create the version of the data. Now, once it is done, I'll just export the data. I'll select this particular download as a zip file, and format wise, I have to select the YOLO v5 PyTorch because I'm going to use YOLO v5. Now just click on continue. See, it has started downloading. Now download is complete. Now if I show you my data, I'll go to the download folder and this is the data it has downloaded. Now let me unzip it and let me show you. The same folder structure actually will get. So this is my folder. Now guys, see, you can see the same folder structure. Now you can delete this 2 file. It's not required. This readme file. This is just some metadata of your RoboFlow. You can also delete the validation one. You can use the test one. Either you can use validation one. So there I kept the test one. You can also keep the test one. You can also keep the validation. Let's delete that valid one. Okay. And now see, this is my training image. So inside image, I'm having the images. Okay. And inside this particular labels, I'm having all the txt file, the annotation file, okay, my actual label. Now same for the testing image also, I'm having the same thing. So this is my image and this is my label. And this is that data.yaml file it has also created. Now let me open this particular data.yaml file. So this is the YAML file. Now we can remove this particular part. It's not required. Now see, this is the actual. Now I can also remove the validation part because validation image I'm not going to use. Okay. Now training image I'll be using for the training purpose, and test image I'm going to use for the testing purpose, testing of my model. Number of classes 6, and these are my all the classes. Now guys, my data is ready, and I think you got to know how to format your data, how to prepare the data, how to perform the annotation and all. So if I open up my Blackboard right now, so this part actually I have already completed. So I already showed you what is YOLO v5 setup. I already showed you, prepared the dataset, custom annotation. And now let's see how we can configure the model and how we can start the training, evaluation, testing on the single image, live object detection, and how to create a web application. So this part is remaining right now. So now let's go to the notebook. Okay, let's go to the notebook. So installation is already completed. Now here, first of all, you have to upload your data. So what you can do, guys, you can just make a zip file of your folder. Let's say this is the data. You can make a zip file. And that particular zip file you can upload here directly. You can upload here directly. Let's say you can upload here. See, there is an upload option. You can directly upload here, and you can use it from here. And there is another way you can read the data. So what you have to do, you have to upload your data to your GitHub. So let me show you. So if you are uploading your data to the GitHub, that means you can read the data from the URL. So I already uploaded my data inside my GitHub. So let me show you. So if I open up my repository, now here I am having one repository called branching tutorial. Inside that, I already uploaded my data. Sign language data. See, sign language data. So this data actually I have already uploaded. So how to upload the data? It's like very easy. You just need to drag and drop. Let's say this is your zip file. This is your zip file. So you just need to drag and drop here. Any kinds of repo you can use, drag and drop, and see it is uploading. So once it is done, you just need to click on commit changes. It will automatically upload. So I already uploaded. I'll just go back, and this is the data I uploaded. I'll open it up. Now just right click on the view raw and just copy the link address, and this is the complete link of your data. Okay, this is the complete link of your data. Now if you click here, it will start downloading your data. See, it will start downloading your data, but I will cancel it. So what I will do, I'll copy this particular link, and here you just need to mention. So make sure you are giving your link. You can also use my link to download the data, but it will download my data. But if you are using your own data, you can upload inside your repository and collect this particular link. Okay. Otherwise, you can also directly upload here. Both you can do. So I'm going to use this particular code snippet. So here I uploaded my data, and I'm doing the unzip operation. Then after that, I'm just using my data set. Now let me show you. So if I just execute right now, first of all, I'm going inside content folder, then I'm downloading the data. Now if you refresh, see, my data has been downloaded, and all the files and folder you can see, my training, okay, training, testing, and data.yaml, everything is visible here. See, inside that I'm having my image. So if you are reading from the URL, that means you don't need to upload the dataset again and again. So this is the convenience, right? But if you are having more dataset, like let's say more than 100 MB, that time actually you can't upload your dataset inside the GitHub. GitHub will give permission denied error, right? At that time you can directly upload inside Google Colab, and you can read from here. See, this is the data. Now I think you can see now data.yaml file is already there, right? So now what I have to do, I already downloaded my data. Now if you just perform cat operation on this particular data.yaml file, that means if you want to read any kinds of content of any file, you can perform cat operation. So this is the command for the Linux. So in Linux, actually, if I want to read something, any file contents, I can use the cat command. So if I just execute cat command, it will show you all the content inside data.yaml. Now if you see here, number of classes I'm having 6. But this particular model you can see here, it has trained with something called Coco dataset. Okay, Coco dataset. So what is Coco dataset? As you can see, they have trained with Coco dataset. Okay, what is Coco dataset? You can search about Coco dataset. So Coco is nothing but it's a benchmark dataset. Okay, it's a benchmark dataset for the object detection. So researcher has already trained this particular model with the help of Coco dataset, this particular benchmark dataset, and it is having 80 classes. This Coco data having 80 classes. 80 classes object it is having, but here I'm having only 6 classes. So here what I'm doing, I'm just taking the transfer learning approach. That means I will be taking the pre-trained model. Okay, pre-trained model. This model is already trained, pre-trained YOLO model. Okay, YOLO v5 model. On top of that, I will train my custom data. That means these 6 classes. Okay, 6 classes I'll be training. Okay, so how to configure this particular model right now with my 6 classes? So for this is the code you have to execute. First of all, you have to extract the NC parameter, that means number of classes parameter. So as you can see, I'll open up this particular data.yaml file with the help of YAML loader. Now I'll extract this particular number of classes, which is nothing but 6. As you can see, it is 6. Now what I have to do, inside YOLO v5, so there is one folder you will get called model. Okay, let me show you. This is the model. Inside that, you are having all the model configuration. Let's say I'm using this particular model called YOLO v5s model. I'll open this particular configuration. You can see here NC is equal to 80. I already told you Coco is having 80 classes. So I have to change this particular parameter. With my actual parameter, which is nothing but 6. So how to change it? So first of all, you just need to copy all the content inside that. Just copy all the content. Make sure you have copied all the content. And here you just need to paste it. Here. As you can see, I have already pasted in this particular cell all the content. Now, before that, you just need to execute this particular magic cell. So this particular magic cell will automatically change the parameter in the cell itself, right? Now see guys, now NC is equal to, instead of giving 80, I have given my number of classes. Okay, this number of classes variable I'm getting, this particular variable I'm giving it here. Okay, now it will automatically change this particular NC parameter and will save this particular file as a custom _ YOLO v5s.yaml in the same folder. Now let me execute and show you. Now if I refresh, so instead of changing this particular file, it has created another copy of the file called custom _ YOLO v5s.yaml. Now if I open this particular file, you can see this parameter has been changed with the 6. So that's how I can do the model configuration change, right? Now you can use any of the model. If you're using N model, X model, you have to do the same thing. Only you just need to change this particular NC classes, right? Now my data is ready, guys. My data is ready. Everything is ready. Now what I have to do, I have to start the training. And if you want to start the training, this is the command you have to execute. there is a file called train.py inside YOLO v5. So as you can see, train.py is there. So all the code they have already written for you, so you don't need to write anything. You just need to execute this particular file and you just need to pass some of the argument. So that's why I personally love this particular YOLO v5. It's a plug and play kinds of package they have created. So by executing some of the command, you can easily train your model. Now I'm executing this particular file YOLO v5 train.py, giving the image resolution size. So you can see my image resolution. It's if I show you my image data, based on the image resolution, you have to pass this particular size. If I show you my properties, if I go to the detail, so this is the resolution of the image. You can see 640 and 480. So that's why I've given this particular size, okay, 416. But if you're using HD image, that time you can give HD image resolution as well, okay, but you can give this particular size. Batch size, you can mention I have given 16 because I'm using free collab. If you are having good configuration machine, at the time you can increase this particular batch size. Number of epoch, as of now I only want to train 100 epoch, but 100 epoch is not enough for the training. Make sure at least you are training 500 epoch, okay, just to get some good output. But just to show you, in this particular video I'm just training 100 epoch, okay. Now here you have to provide the data.yaml file location. This is the data.yaml file location, as you can see. Data.yaml file location. This is the location. So it will automatically load this particular file and it will get to know where is my image is present, where is my annotation file is present, okay. Then you have to give the model configuration. The model configuration you have changed. So inside my YOLO v5, inside models, so this is the configuration file. Custom YOLO v5 s.yaml. Now you have to also give the weight. That means which model you want to use. I want to use this particular model. This model YOLO v5 s. Just copy the name and give it here and try to mention .pt. .pt is the extension of the model, okay. Now you have to give the output location. That means all the model, actually it will train, all the artifact it will generate, everything it will generate in this particular folder only. Now I will start the training. See guys, my training has started. After some time you'll see the epoch and all. See guys, it has loaded the model and now you can see now you can see guys, my epoch has started. So it is running 0 out of 100 and this is the class loss, box loss, everything you can see here, and MAP score. So let's wait. Once this training is completed, I will show you how we can evaluate the model, okay. And inside YOLO v5 folder, you can see it has created one folder called runs. Inside runs, train, and this particular folder, it is saving each and everything, all the results, all the metric, even your training model as well. As you can see, it is saving everything. So let's wait guys. So I'll come back once this training is completed, then I will show you how we can evaluate this particular model. So guys, as you can see, my training is completed and I already got all the classes MAP score and all. And I will show you how to evaluate this particular model and all. So for this, I will be using one metric here. So now you can see in the runs folder, all the artifacts has been generated and this is my best model. That means this is my trained model. So this particular model I will be utilizing for the prediction purpose. And you can see lots of results and batch images has been also saved here. Now let me plot one by one and let me show you what you have to check in the evaluation part. Now, if you want to launch TensorBoard and if you want to check all the losses and graph and everything, you can execute this particular cell. So it will open up the TensorBoard for you and it will show you each and everything. So see guys, this is the TensorBoard and see this is the F1 score. This is the precision curve. This is the, you can see precision curve. This is the recall curve. This is the confusion metric and this is the results, okay. But it's not properly visible. So what you can do, I can show you another way you can check. Now you can also check the GPU you got or not. So here you got Tesla T4 GPU, it's fine. Now there is one image actually it is generated called result.png. Now let's plot this particular image. So this is the code for this and this is the location of that particular result.png. You can see it is available inside this particular folder, result.png. Okay, I'm plotting this particular file. Now you can see this is my complete metric, okay. So by seeing that particular image, actually you can evaluate your model whether it's learning better or not. Now you can see as per my epoch is increasing, loss is also decreasing, every loss is decreasing. So as you can see, this 6 losses should be less as per the epoch is increasing. That means it should be go down. and this 4 matrices should be go up as per the epoch is increasing. As you can see, this is my FAP score. That means, as you can see, this is my MAP score. That means mean average precision, and this is my recall and precision. So you can see my model is learning good. Initially, it was some zigzag issue because initially it happens, it will pick up some random data and all. But at the end, actually, you will see it's learning better. Now you can increase the epoch size. You can increase the like data size. You will see training would be pretty good. Now you can see the evaluation. That's how you can perform the evaluation. Now you can also print some of the batch images. Like, see, this is your actual batch images. Okay. You can also see the ground truth. So these are some ground truth. Even if you see runtime, it has performed some of the augmentation technique. You can see. So it has changed the brightness. It has changed the contrast. It has changed the cropping operation and all. So YOLO V5 by default, it will perform some augmentation for you at the runtime. Now, what I can do, guys, I can show you the actual detection, okay, on top of my test data I'm having. So here is my testing images, guys. So these are my testing images. As you can see inside test image, I'm having all of my images. So now let's load our model, the model we have trained. So this model is available inside YOLO V5 models. Sorry, not inside model. It is inside runs. Then train and this folder, and this is the model. But okay, this is the base.pt. So this is the location I have given, base.pt. The same image size you have to give, and confidence score you can give 0.5, and source is equal to test image. Okay, as you can see, this is the test image location I'm giving. So here is my test image location. Test image location. Okay, inside image I'm having all of my test image, and I'm running one file called detect.py. So it is available inside YOLO V5. So this is the file called detect.py. Again, every code is written inside detect.py. You don't need to write anything. It will automatically load. It will automatically perform detection for you. So now what I have to do, I have to execute this particular line. Now it will pick up all the images, testing image one by one. It will do the detection and it will save inside the runs folder. Let me show you. Okay, so detection is done. Now if you want to see the results, so what you can do is can go inside YOLO V5 folder, and inside runs folder, inside detect folder, it has created detect folder experiment, and see all the detection you can see. So this is hello. See, hello is detecting perfectly with the help of 90% confident it is hello. Now if I show you any other one, let's say I love you. So see, it has detected I love you with 81% confident. And that means detection is fine, guys. I only trained 100 epoch, although my see detection is pretty good. See, no, and please also. You can see this is please, 91% confident. Thanks. See, this is thanks. You can give also. You can also show you the image. Now this is for the yes. Okay, that means all the detection is working fine, and that's actually you can do the image level prediction. You can also keep single image. You can also give multiple image. Okay, this is the image level prediction. So if you want to perform camera level prediction, so what you can do, first of all, you have to set up this particular project in your local machine. Then there actually we can do the camera level prediction. So for this, what you have to do, you have to download only your model. So try to go inside training folder, YOLO V5 results, wait, okay. So this particular model you have to download, base.pt. So click here and try to download this particular model. Okay, so this model I need to the real-time prediction, because see, Collab can't access my web camera. So I have to set up everything in my local machine. Okay, so let me show you guys how we can execute this particular model in our local machine and how we can do the real-time prediction. And I will also show you how you can create the web application. That means web interface. I already created the application. I will show you how it can be integrated. Okay, so let me show you. So guys, I already downloaded that particular model, and this is the application I already created for you. So here I have created all the user app and everything. So what you have to do, you just need to open this particular YOLO V5 folder, and inside that you just need to paste your model. The model you have downloaded, this base.pt. Okay, this model actually we have downloaded from the Collab notebook. So this is my trained model, and this is nothing but my YOLO V5 repository. Okay, I cloned here. So this particular repository I cloned here directly. I cloned this particular repository. Okay, I just copied the link, and here I just done the git clone operation. Either you can directly download and you can keep it here. Okay, and some of the extra folders and file I created, I'll show you what are the changes I have done here. But before that, I just need to set up this particular project in my local machine. Okay, so for this, I'm going to open up my terminal, and I will share this code with you in the resources section. So from there, actually, you can download and you can set up with me. Now here, first of all, I will open up my VS Code. Yeah, so this is the VS Code, and in the README file, I mentioned all the setup. Okay, I think I haven't mentioned. So what I will show you, I'll show you the setup one. So here is the, yeah. So here I will open up my terminal. So first of all, you have to create one conda environment here. So let me create an environment. So you can write this particular command. So conda create -n. You can name this particular name. So I'll give a sign. Okay. You can specify the Python version. So Python is equal to, you have to take 3.8 -y. So this is the command to create the environment. So let's create the environment. Then after that, I will set up everything. Okay, it's done. Now let's activate this particular environment. So this is the command you can execute. Now let me clear. Then after that, I have to set up this particular requirement.txt. So how I collected this requirement.txt, I just went inside this particular folder, and this is the requirement.txt. I just copied. Okay, all the requirements I copied, and I mention it here. So let me show you. And I mentioned in this particular requirements. Okay, see here I mention everything. And apart from that, I also need some additional package. So I kept, these are the additional package here. So I need Flask, because with the help of Flask, actually I'm going to create the user app. Okay, user interface. You can see here I created one HTML file. So in this particular HTML file, I designed everything, all the CSS and HTML code. And with the help of Flask, actually I will render this particular HTML page. Okay. So I have to install these at the library. So what I will do, I'll open up my terminal and I will going to execute this particular command. So pip install requirement.txt. So it will take some time. Once the installation is completed, I will come back. So guys, as you can see, my installation is completed. Now I just need to execute my endpoint. So endpoint is nothing but this app.py I created. And here is the like app implementation. So here I'm using Flask. So if you already know about Flask, I think you know how to use it. So here I'm initializing the Flask. I written one class, client app class. So whatever user is giving input, that image actually I'm saving as input.jpg. And this is the home route. That means if you are launching this particular application, it will render this particular HTML page, okay, index.html. And if you are doing the prediction, you can do the prediction. So it will execute this particular command. It will load your model, okay, and it will do the single image prediction. And this is for the live prediction, okay, live prediction. So yeah, let me use my model base.pt. So here everything you just keep it as default, no need to change anything. Now let me execute and show you how this application will be running. So I'll open up my terminal. So here you just need to execute python app.py. See, your application is running. Now just open your Google tab. Here search for localhost port number 8080. Okay. So this is the URL you have to search, localhost clone port number 8080. And now you can see your application interface. So this is the web interface. Now you can upload any kinds of image and you can do the image level prediction. So let's upload one image here. So I will upload, let's say, one image. Let's say I'm going to upload this particular hello image. Now let's predict. You can also open the terminal and you can see the log. So see guys, detection is completed and you can see the detection right hand side. Okay, that's how you can use this particular user interface and you can like detect any kinds of image. Let's say I'll upload the thanks one. So this is like very easy for the user who doesn't know about the coding and all. So they can use your interface to perform the detection. So this is one basics template I created. See, this is the thanks one. Now if you want to perform, let's say, a live prediction, okay, with your camera. So what you have to do, so here itself, you just need to give /live, okay, /live, and just press enter. So it will open up your web camera and it will do the prediction. Let me show you. So only the change you have to do, that particular model you just need to keep inside the YOLO v5 folder. That's it. Okay, and everything you can keep it as same. You don't need to change anything. So after some times, actually, we'll see it will open up your camera. So guys, now you can see the detect. It has opened up my live camera, but it is detecting some see extra things. Actually, some extra detection is coming because I trained very less epochs, and in my training image, this kinds of background was not there. That's why it's doing some mistake. But if I show you my hand, if you see, it's detecting perfectly. Okay. Hello. Then this is I love you. You have to increase the epoch, then it will detect more actually. So see, I already trained one model actually around 300 epoch. That model, let me just try to run and let me show you. So if you're stopping the execution, so what you have to do in the folder itself, it will create one runs folder. You have to remove this particular folder. First of all, this runs folder you have to remove. Then after that, let me open up my code. So there I kept my model. So this is nothing but my model underscore pt. So this model actually I trained 300 epoch, more than 300 epoch. So this model, let me just mention here in the live prediction. Okay. So instead of base.pt, I'm going to use my model.pt. This model actually I'm going to use. Now let me open up my terminal again and let me execute my app. It's running. So I'll go back. And here I'm going to search for my application. And here let's give the /live. So guys, you can see it has again opened up my camera, but still it is detecting some background because my training image was not like that. So if you want to get a robust model, at a time you have to collect these kinds of image also. Now if I show you, see this is hello. Now this is I love you. Okay. So this is thanks. This is please. So yes guys, that's how actually you can do the live prediction, but you saw that some of the mistakes were there because I trained this particular like model with very less epochs and I was using very less training training images, and it was only from like one background. But if you're collecting from multiple background, if you're training in a good way, you will see the very good prediction there. Okay. So that's how actually you can set up and you can test your application, and here you can give your model, that means base.pt. Let me change this particular name. And there actually I was showing my model. That's why I given this particular my model.pt. This is your model. Okay. So now you can train any kinds of model. You can test with this particular application, and this is the user interface I created. All the codes I've shared with you. Just go ahead and try to check it out. It's like very easy implementation and all. Okay. So yes, guys, I think I have covered all that agenda. So we have seen like how to configure the model training, evaluation, testing, live object detection, and web application part as well. And guys, so yes guys, this is the application building and this is the custom training of the YOLO v5. So going forward, we'll be also doing the deployment. We'll be doing the deployment as a CI/CD with different cloud platform. And this is all from this particular video. I hope you have learned about this particular YOLO v5 like training on top of your custom data, and how we can set up also in our local machine, and how we can do the real-time prediction, real-time detection on top of that, right? So yes guys, this is all from my end. So thank you so much guys for watching this video, and I will see you next time.